Yeah. Today is the third lecture of our IMAT series. Today we are studying atomic structure and electronic configurations. Um, First of all, we start with introduction of an atom. It is the Greek word atomos, meaning indivisible. Uh, Indian scientist Parmano. Okay. Definition of atom. Matter can be broken down into very small indivisible particles called atom. Okay. Matter can be broken down into very small indivisible particles called atom. Uh, uh, Basically what is that, the smallest unit of matter able to undergo chemical reaction. Okay. Structure of an atom consists of positive particles, proton, and neutral particles, neutron, and negatively charged particles, electrons, which electrons are outside the nucleus, revolving in orbits. Okay. View of the characters, you can see here, it suggested that atoms are constantly moving, indivisible, different in shape and sizes, cannot be destroyed. Okay. Okay. Atomic theory of John Dalton. Okay. This is the modern concept, and then they said everything around us is basically like you can say is made up of matter, like atoms are present. Yeah. Atomic theory of John Dalton. Atom is the smallest unit of matter that is composed of a positively charged center termed as nucleus, and the nucleus is surrounded by negative charged particles, electrons, which we call electrons. We call them electrons. Okay. Yeah. Concept of proton, neutron, and electron. The tiny atomic nucleus in the center of an atom consists of protons and neutrons and many other particles. Like proton, neutron, and electrons are the main particles. Okay, larger part of the nucleus is composed of a cloud. Yeah, there is an electronic cloud which we call orbital, which is around the nucleus. Okay, this contains negatively charged particles called electrons. You can see here neutron inside the nucleus, proton inside, and electrons are revolving outside the nucleus. Okay. The attraction between, yeah, this is the important point. The attraction between the protons and electrons hold the structure of an atom together. These protons are here, positive particles, and electrons are negative particles. So this holds the structure of an atom. All atoms are composed of these three subatomic particles except hydrogen. Every particle, like every atom, is made up of these three. Hydrogen has only one electron, so there's only one proton. Okay, like in isotopes, if you are considering isotopes, you can say that neutrons are present, but different isotopes, but one isotope of hydrogen don't have neutrons. Okay. Hydrogen is an exception to all atoms as it just contains one proton and one electron, but it lacks neutrons. This is in general what we study in our periodic table. Okay. Atoms are electrically neutral. Yeah. Atoms are electrically neutral. The atomic nucleus is the structure of an atom. It composed of fixed number of protons and proton attracts the same number of electrons. So as a whole, the atom is neutral. Atom is neutral. There is no charge on atom. Ions are how ions are formed. Ions are formed when atom loses or gains electrons, whether it is a positive ion, cation, or a negative ion, anion. Um, okay. Yeah, you can see here example like we measure weight to balance. Yeah, charges are balanced in the atom, so it is electrically neutral. Concept of electron by J.J. Thomson. Okay, charge on electron is absolute charge on an electron is 1.6 into 10 raised to power minus 13 coulombs. The relative mass of an electron is 1 over 1836. So the mass for an electron is very negligible as compared to proton. Okay. Concept of proton given by Rutherford Goldfoil experiment. Okay. Goldstein used a charge tube, positive charge arrays, another anode rays, canal rays, discovery of protons. Protons are known as the particles that contribute to the positive charge of an atom, charge and mass of proton. Charge of proton is this 1.6 into for electron it is this with my negative charge is right negative here. Okay. So mass of proton 1.6 into 10 raised to the minus 24 grams, 1 mass of hydrogen atom. Okay. Septum neutron James given by James Chadwick, neutron particle discovered in 1932, present in atom's nucleus. Mass of a neutron is by yet to be this. It is equal to the mass of proton. Okay. What is the net charge? Net charge of an atom. Net charge of an atom. Electrons are the negatively charged particles. Protons are the positively charged particles. The equal positive charged particles proton and the negative charge of the electron cancel out each other. So as a whole, an atom is electrically neutral. Okay. Therefore, atom has no charge in an atom that is neutral. The number of electrons revolving around the nucleus. This is for like for this. The number of electrons revolving around the nucleus is equal to number of protons charging. As there is no gain or loss of electrons, so the atoms and protons are equal, and the all atoms are electrically neutral. Okay. Yeah. From the big picture here, we see clearly discovery of the components of the atom and subsequent modeling of the atomic structure led to the explosive advances in chemistry, medicine, and energy. Nature of chemical bond, new molecule sensitive prediction about reactivity, information about how reaction works, electronic computer development, and in medicine, isotope traces, drugs, cancer treatments, nuclear fusion in nuclear fusion, power plants, atomic structure has a role in all of them. Okay. Thomson's flood flooding model for the discovery of electron in 1897. You can see here electrons are like this. Okay. uh, Charge on electron and mass of electron here. Yeah. Finding atomic model, Rutherford, famous world foil experiment. Okay, you can see here details. What is an atomic nucleus? What is present inside the nucleus of an atom? Positive charge particles by Rutherford. You can see it. Like these are values from here. Okay. Current model of atom. Where is Bohr model? Lots of empty spaces, nucleus. Okay. Yeah. Atomic number and mass numbers. What atomic numbers and mass numbers? Number of protons plus number of neutrons constitute mass number. Okay. And the number of protons is called atomic number. The total number of protons present in an atom is also known atomic number, and the total number of protons and the sum of total number of protons and neutrons is the mass number. Okay. Carbon atomic number 6 protons, 6 neutrons has a mass number 12. Carbon atomic number is 6. You can see here protons and neutrons are present here, and electrons are revolving around. The number of protons are equal to number of electrons in case atom doesn't lose or gain electrons. Number of electrons will equal the number of protons for an with no net charge. Okay. Isotopes and atomic mass. What is the difference between mass number and atomic mass? Yeah. It turns out the same element may exist as isotopes. Isotope. What is isotope? With same atomic number, same number of protons and electrons, but a different number of neutrons. Okay. Isotopes of the same atom have approximately the same chemical properties. Isotope of carbon 12. Okay. These are the isotopes of carbon. You can see here C12, C13, C14. Okay. They differ by number of neutrons. In C12 there are 6 protons, in C13 6 protons but 7 neutrons. Okay. In C14 there are 8 neutrons. So they differ by number of neutrons. Atomic mass is weighted average of the mass for each of the isotopes. Okay. What is atomic mass? The AMU, atomic mass unit, is the unit used to express the mass of an atom. 1 AMU is equal to 1 by 12 of the mass of the carbon 12. This is the reference point. We use this for 1 AMU. Okay, 1 AMU is equal to 1.6 into 10 raised to power minus 24 grams or 10 raised to power minus 27. You can write 10 raised to power minus 27 kilograms in case you are given in kilograms. Okay. The mass of one proton or neutron is approximately 1 AMU. Okay. Here's a question. Carbon 12 makes up 98.89%. These are given, percentages are given. You can use this formula and determine the average atomic mass of carbon. Okay, it will be 12.0111 AMU. Okay. Atomic charge and ions. Atoms in elements are not charged because the number of protons are equal. When atoms gains electron more than one electron, one or more than one electron, it gains a negative charge because of imbalance of proton electron ratio. Electrons becomes more than the number of protons. And in case when atoms loses electrons, the number of electrons decreases. Proton electron imbalance takes place, and the charge what the atom contains is positive. And the charged atoms, a cation is positively charged and anion is negatively charged. Okay. Okay, quantum numbers and shape of orbitals. There are basically 4 quantum numbers. Each orbital entry is separately specified by a set of 3 quantum numbers, and each electron is given by a set of 4 quantum numbers. Principal quantum number, okay, it was proposed by Bohr and it was by m. Okay, it determines the average distance between electrons and nucleus, means it denotes the size of an atom. Okay, it determines the energy of electron where all electron is present. Formulas are given here. You can see for radius for electrons. The maximum number of electrons in orbit represents the number of quantum number as 2 and square. Okay, so gives the energy. It gives the information about orbit k, l, m, and n. The value of energy increases with increase in the value of n. It represents the major energy shell or orbit to which the electron belongs. Angular momentum can also be calculated using principal quantum number. Okay, yeah, azimuthal quantum number. This is for angular momentum. Okay, okay. Azimuthal quantum number. Azimuthal quantum number is also known as angular quantum number proposed by Sommerfeld and denoted by L. Okay, it determines the number of subshell or sublevels to which the electron belongs. It tells the shape of subshell. It also expresses the energy of subshell S, P, D, and F. Increasing energy, F orbitals have more energy. The value of L is determined by n minus 1, where n is the number of principal shell or azimuthal quantum number. Principal quantum number. The value of L is equal to, for S it's 0, and for P it is 1, for D it is 2, for F it is 3. Shape of subshell spherical for S, dumbbell for P, double dumbbell for D, and complex for F. Okay, it represents the orbital angular momentum by using this formula. Okay, you don't need to remember this formula. Okay, maximum number of electrons in subshell is found by this formula, 2 into 2l plus 1. Okay, S subshell 2 electrons, D subshell 10 electrons, P subshell 6 electrons, F subshell 14 electrons. So a given value of n, the total value of L is always equal to the value of n. Okay, the energy of any electron is dependent on the value of n plus L. We feel electrons in a suborbit. Okay, the electrons enter the suborbit whose n plus value or the value energy is less. That orbit will be filled first. Suborbit will be filled first, which has less n plus L value. Okay, magnetic formula proposed by Zeeman divided by m or ms. Okay, it gives the number of Fermi orientation of subshells. Its value, the value of m varies from minus L to plus L to 0. The quantum number proved to the Zeeman effect. Yeah, and these are the properties. You can find the total value of m by the formula 2l plus 1. Yeah, these are the orbitals for p, x, py, pz, and for the number of degenerate orbitals for s subshell is 0. Spin quantum number proposed by Goldsmith and Ollenbach. Our symbol is S. And two spins, positive half and negative half. The spin may be clockwise and anti-clockwise. Okay. Maximum spin of an atom is found by this formula 1 by 2 multiplied by number of unpaired electrons. Which is, you can see here, positive spin and negative spin. This quantum spin, remember, the spin quantum number is not the result of solution of Schrödinger equation. Yeah, distribution of quantum numbers. Distribution of quantum numbers here, you can see. Yeah, for all the shells. Yeah, okay. You can screenshot this. Okay. Shape of orbitals S is unidirectional. Yeah, the value of size and energy of S orbital will increase with the value of n. It does not possess any directional property. Shape of P is dumbbell. P has directional properties. P in dumbbell, which two lobes on opposite sides separated by nodal plane. This is the nodal plane here. Okay. Okay. Shape of D is double dumbbell. You can see two dumbbells here. Okay. But DC has only one dumbbell. Okay, shape of fabric complicated solve will not. Electronic configuration principle. There are four principles of power, Hund's rule. Okay, of power, n plus L rule. We discussed n plus L rule previously. Okay, of power rule. What is of power rule? According to this rule, okay, according the lower the n plus L value, the energy lower is the energy of the orbital, and such an orbital will be filled first. Okay, so this is the order of filling of orbital. You can see here 1s, 2s, 2p, 3s, p, 4s, 4p, 5s, 4d, 5p, 6f, 6f, 5d. You can see that 6f has lower n plus l value. FD has 7. FD has n plus l value 7. Okay, this is exception case. Okay, don't need to do this. Okay. Pauli's exclusion principle. According to this principle, no two electrons in an atom can have set of same set of all four quantum numbers. Okay. Okay, these are some important points here. Maximum capacity. Yeah, remember this only. Number of the maximum capacity of subshell is equal to 2 into 2 plus 1 electrons. Okay, and this one as well. Number of orbitals. Okay. Also, according to this rule, electron spinning will not take place in orbital same energy until all the available orbitals of a given subshell contain one electron each with parallel spin. Yeah, you have to these things. Okay. 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 Energy level diagram here. Yeah, out of service. Yeah, you can do. So this is for the today topic. If you find anything you don't understand, let me know. I will help you out. Good luck for the exams. I hope you find this lecture helpful. Yeah, here's electronic configuration and the properties of atoms. So we are studying this now. Electron spin and magnetism. I will see other things as well. Yeah, electron spin and the quantum spin number. You have to prepare quantum numbers as well for the IMAT. Yeah, the magnetic field is generated by the electron spin. Okay, the magnetic field produces an electron occurs in one of the two directions, indicating the electron spin is quantized. Yeah, you can see here in diagram electron spin and magnetic properties. Here how it works. Yeah, spin electron spin. Okay, from here this side or this side. Okay, yeah, spin quantum number. What is the main topic? Okay, spin states are defined by fourth quantum number, the spin quantum number ms. Okay, you can write as m or ms because there are two different spin states. Ms has two possible values, positive half and negative half. Okay, the sign of ms is used to indicate the fact that the two spin states are in opposite directions and should not be confused with the negative charge on the electron. Okay, symbolize electron spin. We find, like, you can say, for example, upward spin and downward spin. Okay, you can use, yeah, this is a representation here. You can see here, if we have three electrons, we will put in the box like this, not like this, not in the same way, not in the same way. We have, like, change the spins, upward direction, and this is the right way. If we have one electron, yeah, we will write like this. Okay, or like this. Okay, types of magnetic material, diamagnetic. This is out of course. You might prepare this for like physics, paramagnetic materials. Okay, orbital energy. Okay, yeah. Okay, relationship between the principal quantum number and the orbital energy. Okay, you have to prepare the quantum numbers first. At least you have to remember. There are four quantum numbers: n, principal quantum number; l, azimuthal quantum number; m, magnetic quantum number; and s, spin quantum number. Okay. 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 Relation between n. Okay. Energy, like, first shell has only one energy level, second has two, and third has three, and fourth has four energy levels. Okay. Okay. The first like number of shells is represented by principal quantum number n. So in first shell we have only two electrons. In the second shell we have 8 electrons. In the third we have 18 electrons, and in fourth shell we have 32 electrons by combining all the orbitals. Okay. Yeah. Here some like sufficient energy increase with increasing level. Okay, sufficient energy increases with increasing L. What is L? This is azimuthal quantum number, the second quantum number. Okay, Sp and D and F are the orbitals. Yeah, these are some important points. As n increases, orbital energy increases for orbitals of the same type. A 4s orbital is higher energy than a 3s orbital. As azimuthal quantum number increases, orbital energy increases. As n is equal to 3, 3s is smaller than 3p and smaller than 3d. As n increases, the energy, sufficient energy becomes more closely spaced and overlapping occurs. Okay. Okay. Electronic configuration of elements. What is electronic configuration? Arrangement of electrons in an atom. You can say like you can represent electronic configuration with the help of quantum numbers or with the help of these rules. The Pauli's expansion principle, yeah, and Aufbau principle. You have to learn this to know how we can balance electronic configuration of an element. Okay, here's Pauli's exclusion principle. To predict the electron for an atom in ground state, the lowest energy state for an atom, electrons are put into orbitals with the lowest energy possible. Yeah, what is the order of filling of okay, it relates to principal quantum number and the angular quantum number or azimuthal quantum number. We There's another name for azimuthal quantum number, that is angular momentum quantum number. Okay, electrons fill orbitals in order of increasing n plus l values. N plus L value. When two or more subshells have the same N plus L value, the electron fill the orbital with the lower N value first. Okay, first we fill that orbital with lower N value when N plus L value of two orbitals will be same. Okay, here you can see 1s has N plus L value 1, 2s has 2, 2p has 3, 3s has also 3. Yeah, this is the point. 2p and 3s, these are like you can say different uh, you can shells. Okay, 2p is less. Okay, but they have same like n plus l values. 3 3. Yeah. Okay, in case of 4 3 and 3d, yeah, 3d has 5. D, the value of angular momentum quantum number for 3d is 5. N plus l value for 3d is 5 because d has value of 2 for angular momentum quantum number. Okay, 4s has 4 because there is the value of s for angular momentum number is 0. 4 plus 0 is equal to 4. So 3d has 5. So we will fill that orbital first, which has less n value. So n value. Okay, Pauli's exclusion principle states that no two electrons with an atom can have the same set of four quantum numbers. Okay, every electrons have at least one quantum number different. Okay, they no two electrons have same set of quantum numbers. Okay, in an atom. Okay, the limits on possible values for the four quantum numbers means a single orbital can accommodate no more than two electrons, and when an orbital contains two electrons, those electrons must have opposite spins. If they have like if two electrons in an orbital present, they have all the values same, but they have opposite spin. Like I told you earlier, this is the opposite spin. You cannot write like this. This is wrong way. Yeah, you can see here only A is allowed. A is correct and B is wrong. Okay. Yeah, which orbital fills first? Tell me, 4d or 5s? You have to check the, first of all, you have to check what you will check first. You will check n plus l value. N plus l value for 4d is 4 plus 2 is 6, and or 5s, 5s for 5s, it will be 5 plus 0. It will be 5 and it is 6. So it will fill, 4d will be filled first. 4d will be filled first. Okay, 4da. Okay. Yeah. Oh, sorry. The n plus l value, the lowest n plus l value will be filled first. So 5s will be filled first. I'm sorry for the confusion. 5s will be filled first. And n plus value is 5, and the n plus value for 4d is 6. So 5s will be filled first. Okay. Is the following electronic arrangement is allowed or not? Tell me. I think we have to write the positive spin first, not this spin first. Okay, so This is not the correct way. It is not allowed. Hydrogen and helium. Electroconfiguration for the periods 1 to 3. Hydrogen has single electron, so we like orientation of hydrogen like this, 1s, and for helium we will like this. We have other quantum numbers. For hydrogen it will n is equal to 1, l is equal to 0 for this electron, okay, and magnetic quantum number is also 0, and so like, and s spin is positive 1 by 2, okay. We have given the values of helium atom. For first electron these values, for second electron these values, okay. They have one different quantum number value, okay. No two electrons have same four quantum number values. Lithium and neon here, okay. You can see here electronic configuration of these two as well. Beryllium and boron here, you can see these as well. Yeah, apply Hund's rule maximum. What is Hund's rule? Yeah, you have to remember this, what we did do in this rule. Yeah, here we have like five you know, we have six electrons in carbon, okay. So according to Hund's rule, we know that 2p orbitals, there are three 2p orbitals, 2p, 2px, 2py, and 2pz. There are three orbitals, okay. Each contains two electrons. uh, After filling four electrons, we are left with two electrons. We will put one electron in each orbital, not like this. We will put, if there's an empty orbital, we will fill half. It is more stable. If we here we are not discussing stability. We will see in the next lecture when we have to do, okay. You can know, according to Hund's rule, if we have empty orbital, we have to, if we have like, if we have one electron, we will fill only first, okay. But here we have two electrons left, okay. We will put one in 2px and one in 2py. If we don't do this, this is the, like, against the Hund's rule, and this will not considered to be correct, okay. Electronic configuration for nitrogen, oxygen, and fluorine and neon are also given. You can see nitrogen, and then nitrogen also follows this rule, and oxygen also following the rule. It is automatic, okay. Yeah, you can see it. So you have to fill at least, if you have empty orbital, if you have electrons, you have to fill the orbitals, other orbitals as well. You don't take I will fill only one orbital completely. You have to see, if you have two electrons, you have to fill other orbitals, like one electron in one orbital and another electron in the second orbital, like in the nitrogen case and in the oxygen case. Yeah, you can put this last electron, yeah, you can put this last electron in 2py, but you have to, you need to put this last electron in the 2pz orbital. That's what Hund's rule explains us. Yeah, and these are the configurations of sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, fluorine, okay. Electronic position for 4 to 7 period, okay. Potassium has this argon configuration plus and 4s1. Yeah, okay. These are some electronic configuration of different elements here. You can see here. Yeah. Here. You are asked to write the electronic in both SPDF and orbital box notation and identify the elements as paramagnetic or diamagnetic. Uh, Zinc is the element with 30 atomic number. Use the filling order to write the electron configuration, keeping in mind. Okay. Like 30 electrons, we have to fill. How? We will put 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10. Total of 30 electrons. This is the notation for zinc. Okay, you have to, like, practice these things to do well. Okay. Orbit orbital box notation, okay. This is orbital box notation, okay. As we know, there is no unpaired electrons, so zinc is diamagnetic. Its electronic configuration shows no unpaired electron. You can see no unpaired electron. All electrons are paired, okay. Okay. Properties of atoms. We will study this in next lectures, okay. Yeah. Write electronic configuration for cations. Yeah. Electronic configuration for cations. There is two Al3 positive, Cr2 positive. You are asked to write electronic configuration. Okay. Aluminium is element 13. It loses 3 electrons and converted into Al plus 3 ion. Okay. Cation. So how will write it has like now it has 10 electrons. First of all, we will write the electronic configuration of aluminum atom, neutral atom. Okay. Then we have write this first of the outer shell will the outer orbitals will loses its electron first. So 3p and 3s are outer. So 3p loses its electron, then 3s. So we are left with 1s, 2s, and 2p. 10 total of 10 electrons. Aluminium gain the electronic configuration of neon, which is a noble gas. Chromium, yeah, chromium. There is a exception of chromium. Okay, you can see here. Uh, as we know, half half 3D half 3D orbital is more stable than the partially. What is partial? Partial is anything like you can say like 3D 4 or 6 3 2, but half field. What is half field? 3D 5 3D 5 half field is more stable. So we'll write um, in place of writing 4s2 4s2 we'll write it as 1. One electron will be shifted to the 3D orbital to make chromium more stable. Okay, because it is more stable. If we feel this 3D is less stable, so we will do this. Okay, when chromium loses 2 electrons, first electron will be lost from 4s. As we know, 4 is the higher orbit. Okay, it will lose its electron first, and then 1 electron from 3D, then 1 electron from 3D. The electronic configuration for chromium Cr2 plus ion will be this like this. Okay, box notations. Okay, anions. Anion forms when atoms loses or gains 1 or more electrons. So chlorine gains 1 electrons here, so it will become negative ion. Yeah. Uh, this is example problem. Draw SPDF and SPDF and orbital box notation for O2 negative and I negative. Uh, do it by yourself. Okay. Try to do it by yourself. Okay. If you have any confusion in these problems, let me know in the comment section. Okay. Ion size. Okay, cations are smaller than the atoms from which they are formed. If we have atom like this, cations will be like smaller than the original atom. Okay, anions will be larger than the original atoms like this. Okay, because electron proton balance, because of imbalance, electron proton imbalance, cations loses electrons, so its size decreases, and anions gains electrons, so size increases. And electron repulsion as well is a factor here. Okay, uh, you need to revise these concepts clearly. Okay, electron exert magnetic pole, like electron and spin magnetism. You have the main thing you need to learn this topic is about spin quantum number. Okay, spin quantum number, not detail in magnetism. Yeah, remember paramagnetism, diamagnetic. Okay, orbital definitions and quantum numbers, principal energy mutual. Okay, spin quantum number. Okay. This is for today's topic. I hope you enjoy the topic. And if you have any confusion related to the topic, let me know in the comment section. I will clear your doubts. Okay, thank you so much. Good luck for the exam.